Welcome everyone. In this video, we will learn mainly about centrifugal pumps. Uh, when I graduated from university and started a job at process industry, I felt that there is a gap between theoretical knowledge and practical application of that knowledge in order to select and size centrifugal pumps. So in this video, I tried to listed out the main steps to select and size the centrifugal pumps with some basic concepts of centrifugal pumps. So if we talk about what is actually centrifugal pump is, so it is defined as it is a rotary machine that converts mechanical energy to a hydraulic energy or pressure by means of centrifugal force, and these pumps are really work great to a medium to low to medium pressure heads with higher discharge flow rate, and the flow rate or the flow through these pumps are pulse free, and they deliver smooth flow rates. And the basic parts of a centrifugal pumps are suction inlet, from where fluid is sucked by the eye of impeller, and the impeller is the rotary part of the pump that insert energy into the fluid. That fluid comes out to the discharge outlet, and the impeller is in placed in the casing, and it is connected via shaft to the coupling, and coupling connects the shaft of a pump to the shaft of a motor, and motor provides electrical energy that finally converts into the hydraulic energy. So these are the some main parts of centrifugal pumps. Now let's move to the selection criteria or the sizing of a centrifugal pump. For that, uh, the first step is you must have to understand, or you must have to calculate the total head or the pressure difference that pump have to deliver. For example, if you install if you want to install a pump to deliver a fluid from point A to point B, so you must know how much is the pressure drop and what would be your final discharge pressure at point B. So by knowing this, you will have a total head of your system. The after calculating the total head, then you will able to find out the pump power, uh, how much kilowatt hour power is required for to deliver this fluid, and then in the third step you have to calculate NPHS for your system. What is NPHS? It's a net positive suction head for your system. We will uh, discuss all these 3 points: how you can calculate total head, how you can calculate pump power and NPSH in coming section of these videos. After calculating these three and knowing the properties and operating condition, particularly temperature and different flow rates for your application, then you should contact the pump supplier and ask for pump curves, and then you should draw your system curves on a pump curves and select the pump with the best efficiency. Sometimes it happens that the condition on which you want to operate a pump are not matching to any pump curves provided by the pump supplier. In that case, usually you can use pump affinity law to generate a new pump curve. In this way, you can even machine the impeller to reduce its size. So these are basically 6 steps to select and to size a centrifugal pump. Now let's go further to the details of each step. So the first thing is Uh, what is pump head? Usually, pump head or the pressure head, pump suppliers does not give you the data in terms of discharge pressure. They provides data in terms of head, because head is constant and pressure of a discharge pressure mainly depends on the fluid properties. If you want to use one pump for water and the same pump want to use to milk, the head of these two pump will be the same, but the pressure will not be the same. The head of a pump is the maximum height at which it can deliver a liquid, and head pressure is related with simple pressure by this formula, where pressure is presented in pounds per square inch, that is equal to the specific gravity of the pumping fluid multiplied by the head in feet divided by 2.3. The head and the pressure, actually it's the main thing is the fluid density. So if the fluid is more denser, the outlet pressure will be lower, but the head would be the same for the same pump. So the total head, if you look on this diagram, the distance from the suction line, from the fluid level in the reservoir up to the center line of the pump is called suction head, and a distance between center line of the pump up to the discharge level is called discharge head, and the sum of suction head and discharge head is called total head. So this is simple and very basic definition. Now let's move to the system head. What is it? It is the amount of a pressure which is required to achieve a given flow rate in the downstream of a pump. System head is further classified into two different regimes. One is static head and the other one is a dynamic head. Static head is created by any vertical column that is attached to the pump, or any attached to the pump suction, or maybe any pressurized system that is connected to the pump discharge side. So the static head it does not change, and in off pump off condition it remains the same. On the other hand, dynamic head varies with the flow rate and shows the energy losses in the system due to the friction, like throttling of discharge valve. And dynamic head is further subclassified into the two different two different classes. One is the straight run head loss, and second one is the fitting head losses. So straight run head loss are actually the frictional losses in a straight pipe, and the fitting head loss is losses of energy due to friction in valves, bands, teeth, and other fittings types. So now we will learn how you can calculate the straight run head loss and fitting head loss. So first, straight run head loss calculation. The approximate method is you can simply use pipe friction monogram charts, which are usually provided by the pipe manufacturer. It is a simple method, but it's approximate method. It's not like exact calculation, but it will give you the idea how much straight run head loss will be for a particular pipeline. These chart, what they show, for example, if I enhance the size of this chart, and you will able to see. So here there are four columns. Number one is internal diameter of a pipe, Number two is flow rate, flow velocity. So you have to take a scale and then you have to make a straight line that connects your operating conditions, like what is your pipe diameter, what would be your flow rate, and what would be your flow velocity. So the line that matches all these 3 points will cross to the fourth line, that is the head loss in meter per 100 meter of a pipe. So in this way you are able to calculate straight run head loss, but this method is again for approximate calculation. The second way to do this calculation is use simply Darcy-Weisbach equation, and this equation states that the straight run head loss is equal to the friction coefficient, length of your pipe, velocity square of your fluid, diameter of your pipe, and gravitational acceleration. Using this equation you will have straight run head loss for your system. So now move to the second type, that is the fitting head loss calculation. For this usually k-value method is used. What is this? Each type of wall, T and bend have a characteristic k value, that is a friction coefficient, and these k values can be consulted from Paris Handbook of Chemical Engineering. So there is a big table that have all the k values for each and every type of wall, bands, T's, and all other fittings. And then you should count all the valves and fittings on a relevant suction or discharge line from plant PIDs, process instrument diagram. After that, add these K values for all the fittings and walls to get the total K value, and use the following formula to find the fitting head loss calculation. And the formula is fitting head loss is equal to the friction coefficient, that is K, and velocity, superficial velocity of your fluid, and gravitational acceleration. So now after calculating these two, you are able what the addition of static head, that is not going to change, then the fitting head losses and the straight run head losses will give you the total head that pump needs to generate to overcome the resistance to deliver the specified flow rate to the systems. So now you are able to calculate the total head loss or the total pressure that pump have to deliver to the fluid in order to move it from suction line to the discharge point. Another important aspect that you have to calculate it a net positive suction head. What is it? It is the minimum pressure that must be present at the pump suction to avoid liquid boiling and resultantly cavitation. Uh, what happen first, I will explain how you can calculate net positive suction head for your system. So the formula is absolute pressure on your reservoir, suction reservoir, minus the vapor pressure of your fluid, the density of your pumping fluid, gravitational acceleration, plus the elevation or the distance from the reservoir level to the pump level, and HF is the friction losses in the suction line. So if you can see here in this picture, so this is the suction reservoir, and P naught is the absolute pressure or the atmospheric pressure in this case on the on a reservoir, and the distance between level of a liquid up to the center line of a pump is Z, and the friction losses in this line is HF. So using this formula, you will able to find NPSH, net positive suction head, for your system. The vapor pressure is directly linked with the temperature. So I would recommend you just make an Excel sheet and use this formula, that is the Antoine equation. For different temperature, calculate the vapor pressure, and because your pump is going to operate in winter and in summer, so you must know that your pump should work all the temperature range in particular area. For example, if in winter the temperature is like maybe 1 to 2 degrees C, and in summer it goes up to 30 to 35 degrees C. So you must calculate the vapor pressure and finally NPSH at different temperature in order to show that your pump will work greatly in all these conditions. So the next is cavitation. That happens due to the low NPSH compared to the required. If the NPSH, net positive suction head, is lower than the required, what will happen? Due to the low pressure at the suction of a pump, the pump will vaporize or boil, and the vapor or the air bubbles will start to collapse in the impeller due to the low pressure zone, and they will continuously hitting the impeller, and it will cause you the erosion and pitting on a material that will definitely decline the pump performance with time. So we have to be sure that our system is not going to face cavitation. Uh, so this is important concept. Now you have learned how to calculate the total head, how to calculate a net positive suction head. The third step that you must know before going to the pump vendor is the pump power. So using uh, total head after the system head calculation, now you can calculate the pump power, approximate pump power, using the following equation. Actual pump required power, power required for pumping a particular fluid is equal to the outlet or the discharge pressure minus suction pressure multiplied by flow rate divided by the liquid density multiplied with efficiency. If you do not know the efficiency of a pump, so take 0.7 as a first approximation, and then consult the pump supplier how much is the efficiency, but it will give you the basic idea how much kilowatt power motor is required for pumping a particular fluid for your application. After that, we will discuss now the pump performance curves. Pump heads and the system head, these two are plotted in terms of curves, and pump performance curves pump performance curves are usually delivered by the pump manufacturer, and they test pump under different conditions in their labs and generate these curves, which mainly used to select the right centrifugal pump for an application. For example, they have this kind of setup. They have pump, they have pressure indicator at a suction, pressure indicator at discharge, and flow indicator. So they operate pump at different flow rates and check the suction pressure and the discharge pressure and convert these pressure into the heads, and then they simply draw different flow rates against different head. So this red line is a pump head curve, that decline with increasing flow rates. On the other hand, pump efficiency increases with increasing the flow rate up to a certain point, and then it decreases sharply. Pump power consumption increases continuously with increase of flow rate. Similarly, the NPSH requirement for a pump also increases with the flow rates. So these are the curves which are provided by the pump supplier or pump vendor, and these curves are for single impeller and fixed speed. For single impeller fixed speed, there should be only one characteristic curve for a pump. Now let's move to the other things. In sometimes the impellers, the same pump have possibility to change different impellers. With in decreasing the size of impeller, for the same flow rate, the head will decrease. Also, the efficiency of a pump decreases with decreasing the impeller size for a same pump, because in this case the energy losses increases. Similarly, now in markets there is also option available for variable speed pumps. So for each speed they have a different pump curve, and at higher speed higher head, at lower speed lower head, and again the efficiency of a pump is higher at higher speed, but the power consumption is also increases. Now the when you have your system curve, you know your total system head, you can plot a curve on a pump curve diagram. If your system do not have any static head, then your system curve will start from 0. But if your system has some static head, then it will start from that particular value. And the point where the system curve and the pump curves intersect each other, it is the operating point for your system. Okay, now let's check some more complex pump curve that usually pump vendor provided. In this pump curve, you can see there are different pump curves for different impeller size. With increasing the impeller size for same flow rate, the head will increase. On the other hand, the efficiency of a pump is increases with the impeller size. Also, the power consumption increases with increasing the flow rate. You can see 5 horsepower, 7, 10, and then 15 horsepower. And NPHS requirement is also increases with increase in the flow rate. So now this is the basic concepts and the basic steps that you have to take to size and select the right centrifugal pump. I hope you understand the basics. Now in coming video we will calculate pump power and pump efficiency for a particular application in Aspen HYSYS. So if you like the video, please like and subscribe my channel. See you in coming video. Bye bye.